So once we finish this assembly, we can move to the kinematic analysis. So you move your mouse to the very top of this interface and choose environment. There are some analysis you can perform by using Inventor. And in this lecture, we are going to use dynamic simulation. So you can perform kinematic analysis in this dynamic simulation. So you click this one, it will bring you into a new interface. So it will ask you if you want to start a dynamic simulation tutorial. Well, for now, we don't need it. But if you like, you can click yes and to see a tutorial. But anyway, here I choose no. So we'll do it by ourselves. Let me change the view. Okay, so now this mechanism is ready, and we need to assign the input for this mechanism. So here I'm going to assign angular velocity for this link. So it's like I'm going to install a motor to drive this link to run certain angular velocity. So you can see a tree list here. And here it shows all the links and also all the joint. There are some like arrow here, redundant, but you can just ignore them. As long as your linkage is movable, you can just ignore them. And so I'm going to place a joint, sorry, not joint, an actuator. I'm going to apply a motion on this revolution joint or rotational joint, the number 1. When you move your mouse here, you indicate which joint is referring to. So revolution 1 is this one, revolution 2 is this one, etc. So I will assign a movement for this rotational, revolution number 1. So you right click on this joint and select properties. So in property, there's a new window shown here. Then you move to DOF1 and R. This one is for the R joint. And you can assign the value, the position, the velocity, and maybe only velocity, sorry, no acceleration, because acceleration will be obtained by velocity. Okay, so here you can determine, you can move your mouse here, it will show you what this icon means. The first one means is the initial condition. That's our current step. So position means the position of this joint. So right now it's 51, 70 something, but you can move it to 0 and to see how it's going to work. So you press, you type 0, then it will become 0 degree. Or you can type 90, and it will be 90 degree. So that's for the position. And there's an option here called joint torque. We don't need this now, but if you want to do the dynamic analysis, you want to perform the force and mass analysis, then you will use this one. But for our kinematic analysis, you will just use the imposed motion, the last one, the last icon. So click this one, the interface will change. And there's an option here called enable imposed motion. Click this one. Yeah, so imposed motion means you are going to assign a motion to the joint. And the default option is the velocity. So that means you can assign velocity. You can click this one. There are two options here. One is the input grapher. The input grapher means you can determine a complicated motion. But if you just want a constant value, you can select the first one. So right now, let's just try the constant value. So I'm going to assign the angular velocity of 120 degrees per second. So that means if I run this mechanism for 3 seconds, it will have a full rotational motion for the first for this purple link. So I click OK, and that's it. Then we finish the setting for the input. And right now you probably notice this one, and let's do something for now. This player is indicate how long you are going to run the simulation. So the default value is 1, but I set 120 degrees per second, so I want this mechanism to run for 3 seconds. Then it will have a full rotational motion. And the second one is the frame number. The more frame, that means your animation will be more smooth, or the step will be smoother. But usually I think 30 is enough. But this is up to you. You can use should be 90. So I like 30 frames per second. So for 3 seconds, I set 90 frames. So remember that the higher number this one is, that means you will need more time to perform the simulation. The computer will run longer to finish the simulation. So you can make your increment very small, but you just need more computing time. So here I set the value to 90 degrees, and let's see how it works. Then once you finish the setting, you can click this run, and this mechanism is going to run for 3 seconds. So we finish the simulation.